For this problem, it says to determine the number of ladybugs in the following diagram by multiplying, and it wants us to start by identifying the multiplication model, and then write the multiplication setup equation, including our units, and then find the correct answer with those units. So we can see we have ladybugs that are arranged in an array. So for the model here, this would be area of an array, because we have rows and columns. Or if you've got length and width, that would also be area of an array. And so for the multiplication setup, the general form for this for area of an array is we would take the number of rows times the number of objects per row. And that would give us the total number of objects. But we're going to do it specific to this problem. So in this case, it is going to be rows. How many rows do I have? Well, I've got 1, 2, 3, 4, 5 rows. And then in this case, my objects are ladybugs. And so then how many do I have in each row? 1, 2, 3, 4, 5, 6, 7, 8 in each row. So we'll say times 8 ladybugs per row. And then that should equal, we'll use a question mark because that's what we're trying to find. And in this case, we would say that this is ladybugs. If you write total ladybugs, that's also fine. You don't have to write the word total, but if you like to write the word total, you can. But definitely put ladybugs there. All right, so then this is enough information that we could find the correct answer. You could technically find it by counting, although the faster way would just be to multiply 5 times 8. And in this case, we get 40. You could write either total ladybugs or just ladybugs. So then let's take a look at the next one. This says Fran has 3 pairs of pants, khakis, yoga pants, and jeans that coordinate perfectly with 4 different shirts, green, blue, pink, and navy. How many different outfits consisting of a pair of pants and a shirt can Fran make from these choices? So we're talking about finding like total numbers of combinations, right? So that makes this model I'm just going to call it counting. We technically called it counting / list / ordered pair / trees. So I would just say for simplicity, let's just call that counting. And then we're going to write the multiplication setup. Usually it doesn't really matter on this one, like you're doing the number of choices for one thing times the number of choices for another. It doesn't really matter which comes first. Typically, I would just do it in the order they told it to me. So since they told me about the pants first, I'll do pants. So we had 3 choices for pants. So you could say pant choices or choices of pants. You could phrase that different ways. Times, then we would multiply that by, we had 4 shirt choices. And then this is an equation, so it does need the rest of this. It does need an equal sign. And in this case, we'll say equals. So then I'm trying to find the answer. And this would be you could say total choices, total combinations, total outfits. Any of those would probably be acceptable. All right, so it kind of ran onto 2 lines just because I ran out of space there, but that's okay. So then let's draw a tree diagram. It wants us to use the underlined letters in each item. So they're telling us like they've underlined K for khakis, Y for yoga. So that should help make things a little bit easier. I don't have to pick abbreviations. You can do your tree diagram like from the top down, or you can do it left to right. It does not matter. I'll go ahead and do it left to right. So starting with pants, since I had 3 pants, that means that my root is going to start with 3 branches coming off it. And let's use khakis, yoga pants, jeans. And then off of each one of those, I'm going to do my shirt choices, and I had 4 shirt choices. So that means each one of these, I'm going to have to cram it in here, but each one of these should have 4 branches coming off of it. basically saying if I chose to wear khakis, I could then choose to wear either the green, blue, pink, or navy shirt. But if I chose yoga pants, I could also choose either the green, blue, pink, or navy. If I chose jeans, same thing. I could choose then green, blue, pink, or navy. I'm using capital letters. I think technically they've got lowercase. It shouldn't make a difference. And so then I could just count every single combination, or if you wanted to list them, you would just follow every branch. So like, I don't know that I'm gonna list them all out here, but I'll start. So like I could have khakis with the green shirt. The next branch down is khakis with the blue shirt. The next branch is khakis with a pink shirt, then khakis with navy. Then the next branch down is yoga with a green shirt, right? So I could just list all these out. Really though, all I need to do if I just want to know how many is just count the total number of ending branches. So I'm not going to make the list, but you could. What I should be getting here is that there are 12, which makes sense because that was 3 times 4. So there are 12 total choices or total outfits, or 12 total combinations of shirt and pants. All right, and then let's take a look at the last one here. So this says Ava's puppy weighs 9 pounds. Micah's puppy weighs 4 times as much as Ava's puppy. How much does Micah's puppy weigh? So we're comparing, right? We're talking about Micah's weighs this many times as much as Ava's. So this would be a multiplicative comparison problem. So for this model, the number of objects we have is the first number in my multiplication setup. In this case, it would be Ava's puppy, we know is 9 pounds. So we could say 9 pounds times however many times as much or times many. So in this case, 4 times as much. And then we're trying to find then, this would still be in pounds, right? So this is 9 pounds for Ava's puppy. Micah's is 4 times as much. So then we're trying to find the number of pounds for Micah's puppy, right? So still in pounds. So then this says to use a strip diagram or number line for this problem. You did not have to do both. I will go ahead and show both just so you can know if yours is correct. So if I started with a strip diagram, I would start with, we knew that Ava's puppy was 9 pounds, and you can make that really any size you want. So I just drew a rectangle to make 9. And then I would just do my best to repeat that same size. So however big you drew it, do that again. So the first 9 would be 1 times as many. So if I do another 9, that's now 2 times as many. I'm trying to go out to 4 times as many. So this is 3, and then this is finally the 4 times as many. So this would be my strip diagram. And if you want, you can label those, you don't have to. And then we could just find this by doing repeated addition. Or you realize like, hey, you can multiply 9 times 4, right? So 9 plus 9 plus 9 plus 9. And so that's going to give us 36. And then that is in pounds. So we're saying that Ava's puppy was 9 pounds. Micah's 4 times as much. So Micah's puppy is 36 pounds. Big puppy. So then the number line, same idea. You would start at 0. And then I would essentially count by 9. So you don't necessarily have to put all the tick marks. If you want to, if that's helpful, you can. But really, we're just saying, okay, this is where we start with Ava's puppy. And then 2 times as many. Add 9 more to that. That would take me out to 18, right? So then 3 times as many, do 9 more. That would take me out to 27. And again, you could just count those, right? So you could count, 19, 20, 21, count 9 more. And then, so now this is 1 times as many to 9, 2 times to 18, 3 times to 27. So then I'll do 1 more to do 4 times as many. And I should end up at 36.